Welcome back. So day 3 is a bit of a step up in difficulty compared to the first two, but it's still very manageable. What we get is this 2D grid of numbers, periods, and other symbols like asterisk and hashtag, whatever, dollar sign. And our mission is to find all the part numbers. Part numbers are numbers that are adjacent to a symbol, even diagonally. So this one is a part number because it's diagonally adjacent to this one. This one is not a part number. There are no symbols around it. And the same is true of this one right here, but all the other ones are part numbers. If we sum up all the part numbers, we get our puzzle answer, 4,361. So how do we do this in Python? What we could do, the approach I took was I first searched for all the locations of the symbols, this one, this one, this one, so on, and then iterated around them, like this, this, and this, and added all of these coordinates to a big set of a set that I called adjacent or something. And then I iterated again through this whole 2D grid, and this time I was looking not for the symbols, but for the numbers. And if I found a number, I would check all the coordinates if they were in the adjacency set that I created earlier. And if they were, then they were part numbers. If they weren't, then they were standalone numbers that didn't have any symbols adjacent to them. So let's see how we code this. We start off importing the regular expression module, which is always a good idea. Then we split the 2D grid into individual lines, and then we're going to come up with two regular expression patterns, one for the symbols, one for the numbers. One for the numbers is pretty easy. Maybe we do that one first. We just do /d with a plus sign. The plus sign is to ensure that we match multiple digit numbers. The other one, we use brackets and a caret. So this means everything but, and then we write digits or periods. Anything but digits or periods is what we're looking for. That's a symbol. We iterate through the lines and match all of the symbols. We could use find all. The problem is if we use find all, we only find the symbols themselves, but we also need the indices of the symbols. So it's better to use find iter. Find iter returns these weird objects. If we unpack them, we see it has a span attribute and a match attribute. We're interested in the span, specifically the beginning, the first number. We can access it using the keyword start. So we take each element, look at the start. There we get it, 3, 6, 3, 5. That looks about right. 3, 6, 3, and 5, and so on. So, but we also need the row. We can get that through the enumerate function. And let's call this the column, and this not I, but row. So we get the row and the column. And now we're going to create our adjacency set. It's better to use a set than a list because a set has faster lookup times. A list just takes longer, it's less efficient. And now we iterate around the coordinates of the symbol by going row -1 up to row +2. Remember, the right side of any range is non-inclusive, so we have to add one more. And then we add that new coordinate to our adjacency set. This is like 4 nested for loops, which is pretty ugly, so let's see if we can make this a bit more pretty. We can use a set comprehension, similar to a list comprehension. And this will collapse 2 of the for loops into one line, which I think is pretty nice. And then the resulting set, we add that to the original set using the method union, make a union of both sets. But we could even reduce this into one line by using the OR operator. We take anything that's in the first set or the second set, and that'll be our updated first set. So it's the pipe equal operator that we're using here. Similar to plus equals when you're talking about numbers. Now over to the next step, we iterate again through all the lines. This time we're not looking for symbols, we're looking for numbers. And we're using findItter again because we don't only need the numbers but also their indices. We can access these indices through start and end, but there's actually another way. We can also just use the span method and iterate through that span. So we use column in numbers span, and we print the column, see if it works. It's not working. We just get apparently the span is just a tuple, it's not a range. So what we need is a range of that span. That doesn't work unless we unpack the tuple first. Now it works. Now for each number we have to check, is there any coordinate of this number that overlaps with the symbol adjacency set? So for this, I think the most straightforward way to do this is to use Python's any function, which can accept any iterable, like a list or a set, and if any of the elements inside of the list or the set are true or positive or whatever, then it returns true. So what we do is we make a little generator expression inside of this any function. If the coordinate is inside of the symbol adjacency set for all the coordinates inside of the span for the number, then that number is a part number, and it matters. We need to add it to the total. So we need to retrieve its actual number value. Right now num is still this weird match object. To retrieve its value, we need to call the group method and then add it to the total. See if this works. It does not, because it's still a string. We still have to turn it into a number. And now it works. And there's our answer. So for part 2, what we need to do is find the gears. A gear is a asterisk symbol. It has exactly 2 numbers adjacent to it. So here we find a gear because it has this number and this number. Here we find a gear because it has this number and this number next to it. This one is not a gear because it has only one number to it next to it. If we find gears, we need to multiply their respective 2 numbers with each other and then sum up all of those products, and that'll be our answer. How do we do this? My suggestion would be the following. We search for all the coordinates of the asterisk symbols, add them to a dictionary, and initialize their value as an empty list. And what we want to do is add all the numbers to that list that are next to it. And if the length of that list is exactly 2, then we know that this is a gear. If it's not, it's not. So first we do the dictionary with the empty lists, then we iterate again through the grid, find all the numbers, iterate around the numbers. For example, here we go above it, left to it, right of it, and below it. And then we stumble upon this, and if the coordinate is in the dictionary, we add it to the list of that dictionary entry. Let's do it in Python. Again, we pick up where we left off. We remove some stuff that's not useful anymore, but add other stuff. For example, we need a regular expression for the gears, because now we're not looking for symbols, but gears, asterisks. Let's skip the total for now. Maybe we reintroduce it later. But what we need is a dictionary for gears, where the gear coordinates will be the keys. Let's call it gears. And we iterate through the lines, find all the gears, and add them to the dictionary with empty lists as values. This is where the numbers will go. Now we iterate through the lines again, find all the numbers, and then iterate around each number. So start one row earlier and end one row later. Iterate through all the columns. Again, we can use the span method here. And if those coordinates around the numbers are in the gear dictionary, then that means we found a gear, and we add the number to the gear using append because it's a list. And the number, we have to retrieve it again using the group method and making it an integer. Now we iterate through all of the gears, and if the length of the numbers that belong to the gear is exactly 2, then we add the product of those two numbers to the total. Again, we can use the math product function here. So we import the math module, and then we just print the total. And it's 0, so something's wrong. Let's check what's up with the gears. Yeah, they're not getting all the numbers they need. And there it is. We can't just use the span because we have to start before the first column and end after the last column. So we use the start and end methods instead of the span. And now it should work. Yeah, it works. Perfect. That's it, part 2.